Have you ever wondered if there's another Earth-like planet in the cosmos? In our quest to answer this question, we've delved deeper and deeper into the vast unknown, exploring the stars and their celestial companions. This search has led us to the discovery of exoplanets, planets that orbit stars outside of our solar system. And among these newfound worlds, there's one that has sparked a particular interest. Its name, Kepler 69c. In 2013, this intriguing planet was discovered by the Kepler spacecraft, a space observatory launched by NASA to search for Earth-sized planets in the habitable zones of their stars. Named after the spacecraft that discovered it, Kepler 69c is part of the Kepler 69 system, which is located about 2,400 light-years from Earth. The Kepler spacecraft, using its photometer, measures the brightness of stars over time. When a planet passes in front of its star or transits, it causes a slight dip in the star's brightness. By observing these dips, the Kepler spacecraft identifies potential planets. This is precisely how Kepler 69c was discovered. The 69CE in its name indicates that it's the third planet discovered in the Kepler 69 system. You see, the first planet discovered in a system is designated B, the second CE, and so forth. So, Kepler 69c is not just the third planet in the Kepler 69 system, but it's also the third planet discovered by the Kepler spacecraft in this particular star system. This discovery of Kepler 69c has opened up a world of possibilities, not just for astronomers and scientists, but for all of us who've ever looked up at the stars and wondered, are we alone in the universe? Kepler 69c, like other exoplanets, provides a tantalizing hint that the answer to this question might be more complex and more exciting than we ever imagined. So what makes Kepler 69c so special among the thousands of exoplanets discovered? The discovery of Kepler 69c is a testament to human ingenuity and our quest for knowledge. Kepler 69c, an exoplanet that sits over 2,000 light-years away from us, was discovered not through a telescope peering into the depths of space, but by a spacecraft named Kepler, launched by NASA in March 2009. Kepler's mission? To seek out Earth-like planets orbiting other stars, to find new worlds in the vastness of the universe. Kepler is our cosmic matchmaker, pairing us with planets that could potentially be our new celestial homes. But how does Kepler find these exoplanets? It uses a method known as the transit method. Picture this. As a planet passes in front of its star, it causes a tiny, almost imperceptible dip in the star's brightness. Kepler, with its sensitive instruments, can detect these small dimmings. Each time a planet orbits its star, it causes this light to dim, and each dimming is a telltale sign of a planet's existence. So, in May 2013, as the data streamed in from Kepler, a pattern emerged. A star, Kepler 69, showed these telltale dips in brightness. The team of astronomers and scientists held their breaths as they confirmed the data. This was it. They had found a new planet, Kepler 69c. It was a moment of triumph, a culmination of years of hard work and perseverance. The discovery was met with excitement and anticipation. What could this new world hold? Could it be another Earth? But this was just the first step. The discovery of Kepler 69c had opened a door to a new world, but what lay beyond that door was still a mystery. The analysis and study of Kepler 69c would take years, as scientists pored over the data, trying to understand this new planet. It was a momentous discovery, but it was just the beginning. But the discovery was just the beginning. The analysis and study of Kepler 69c opened a new chapter. Scene script. Once discovered, the real work began, studying Kepler 69c to understand its potential for life. So, how exactly do we study an exoplanet that's over 2,400 light-years away? Well, the answer lies in two primary methods: light curve analysis and spectroscopy. Light curve analysis is a way to measure the tiny dip in a star's brightness when a planet crosses in front of it. By observing these minuscule changes, scientists can determine a planet's size and orbit. As for Kepler 69c, this method revealed that this exoplanet is only around 1.5 times the size of Earth. It also orbits its star, a sun-like entity known as Kepler 69, in about 243 Earth days, a bit closer than Venus is to our Sun. Spectroscopy, on the other hand, allows us to study the planet's atmosphere. By analyzing the light that passes through the planet's atmosphere, we can identify the chemical signatures of different elements and molecules. Although we haven't been able to probe the atmosphere of Kepler 69c yet, spectroscopy will be a key tool in our future investigations. Now, when it comes to temperature, Kepler 69c is quite intriguing. It's estimated to have an equilibrium temperature of around -25 degrees Celsius, which is a little colder than Earth's average temperature. However, we should keep in mind that this is a rough estimate, and the actual surface temperature could be influenced by a range of factors, including the composition of the planet's atmosphere. Studying exoplanets like Kepler 69c isn't without its challenges, though. These planets are incredibly distant, their signals are faint, and their host stars often outshine them, making them difficult to observe. Nevertheless, the scientific community is continually improving its techniques and instruments to overcome these hurdles. With all this data, scientists began to form a picture of what life on Kepler 69c might look like. The million-dollar question: could Kepler 69c support life as we know it? To ponder this, it's crucial to understand the concept of the habitable zone, often referred to as the Goldilocks zone. This is the region around a star where conditions might just be just right, not too hot, not too cold, for liquid water to exist on a planet's surface, a key ingredient for life as we know it. Now let's talk about Kepler 69c. This exoplanet is located near the inner edge of its star's habitable zone. This might make you think, great, it's in the Goldilocks zone, so it's habitable, right? Well, not so fast. Being near the inner edge means it's closer to its star, Kepler 69, and this might make it too hot for life as we understand it. Think about it as being close to a bonfire. It might be too hot to handle, but heat is not the only factor to consider when assessing habitability. What about water? We've yet to find definitive proof of water on Kepler 69c. However, its position in the habitable zone does raise the possibility, and further studies are needed to confirm this. Other necessary conditions for life include a stable atmosphere and the right chemical elements. Again, we don't have conclusive evidence that Kepler 69c ticks these boxes. But remember, our knowledge of this exoplanet is still growing, and future studies might bring us surprising insights. So could Kepler 69c support life? In the current state of our knowledge, it seems unlikely. But this doesn't mean that Kepler 69c isn't important. Far from it. Its discovery has helped astronomers refine their techniques for finding and studying exoplanets, and it's opened up a new realm of possibilities for where we might find life beyond our solar system. While Kepler 69c might not be a second Earth, its discovery has undeniably broadened our understanding of the universe. Kepler 69c may not be our next home, but it's still a significant step in our cosmic journey. As we venture further into the unknown, the study of Kepler 69c has become a beacon, guiding our understanding of exoplanets and their potential for habitability. By examining this distant world, we've learned crucial lessons about the variety and complexity of exoplanets. From its size and composition to its orbit and atmospheric conditions, Kepler 69c has taught us that exoplanets are as diverse as the stars they orbit. It's a vivid reminder that our search for an Earth-like planet is far from over, but also that our universe is teeming with possibilities. Looking to the future, our exploration of exoplanets is set to take another giant leap. The launch of the next generation of space telescopes, such as the James Webb Space Telescope and the European Extremely Large Telescope, will allow us to probe deeper into the cosmos. These technological marvels will not only enhance our ability to detect exoplanets, but also enable us to study their atmospheres in greater detail than ever before. We're also on the cusp of a new era in space travel. The development of advanced propulsion technologies promises to shorten our journey time to distant stars, opening up the possibility of sending probes to exoplanets within our lifetime. Imagine, not just observing these alien worlds from afar, but actually touching their surfaces and analyzing their soil. The future of exoplanet exploration is undoubtedly exciting. It's a journey of discovery, driven by our insatiable curiosity and our enduring hope of finding a world that could be a second home for humanity. We've come a long way since the first exoplanet was discovered in the early 90s, but we're still at the very beginning of this cosmic odyssey. As we continue to gaze at the stars, who knows what we'll discover next? Our cosmic journey is only just beginning.